Okay, so hello everyone. So today I would like to present my FYP which titled the Predictive Analytics for Energy System. Hope you enjoy it. So first, I will give you an outline of what I have done. So what's the background, motivation, and this the one I propose, it to face, experiment results, demo, and also the conclusion that I've reached after the experiments. So first, on the background, so what are we trying to solve here? So what are we trying to solve is a time series problem, which is actually a sequential set of data points measured typically over successive times, which can be formulated as you can see here. And two of the examples are maybe the aeroplane data, passengers, and also the Google stock price. Yeah, so these are data that we are trying to solve. And then, what's the motivation? So first, the time series problem has some challenges that we want to try to solve, which is the system dynamics and also the uncertainty, error, and noises. So how do we solve that? We use a fuzzy system and also memory neurons to incorporate into our neural network system. So first, let's talk about the way to freeze, which is the one that we propose in this FYP. So first, it to freeze has many foundation, which is the neural network, fuzzy system, interval type 2 fuzzy system, and memory neurons, which I'll explain in the next slide. So first is the neural network. As you can know, it's very famous here. Computing system inspired by biological neural network. It has a neuron and layers, three layers, input, hidden, and output, which the hidden has many layers if we want. So as we can see here, next is the fuzzy system, which is based on the fuzzy logic, which is very different from the Boolean logic, which has the value of between 0 and 1 compared to the Boolean, which is 0 or 1. Value can be partially true. For example, here we have is it cold? In the Boolean, we can have 1 or 0, which basically means yes or no. But here, if we have 0 0.9, 0 0.25, and 0 0.1, which means that it's maybe very much cold, little, or maybe very less. Next, we want to incorporate the fuzzy system earlier, and we extend it to have the interval type 2 fuzzy system. But first, let me explain what is type 2 fuzzy system, which basically is the extension of type 1 fuzzy system, which has the second membership function. So that means that in the value of the membership function itself is a fuzzy value. But as we know, the more complicated it is, they become high computational cost. So yeah, we have to make it simpler by having an interval type 2 fuzzy system, which can have a membership grade, which can be 0 or 1. Yeah, if we do this, we can reduce the computational cost. So we have the upper MF and the lower MF, which MF stands for membership function. So as we can see here, memory neurons is very important because we want to take down all the past data, past instances of the data, and it has a mechanism to have the data that is older to become less significant than the new one. And then, what is it2Fs good for? First, it's good for robust against error, uncertainty noises because yeah, that's the memory neuron. It has the fuzzy system is good. And also we have an innovation here, which is the rule initialization or estimation. So yeah, using the K-means algorithm, we can have this property. And the last one, and we have the gradient descent propagation approach, GDBP. Yeah, it will be explained further, and also we can capture the past instance because we have a memory neuron. So a little bit about the architecture. As we can see here, we have 6 layers, which basically consists of input, hidden, and output. The input and output is quite obvious, so I will not explain too much here. But let's get into the hidden layer. So the hidden layer, we have 4 here. The first one is a falsification layer, which basically, like we already discussed earlier, is a type 2, interval type 2 membership function, which basically has the lower and the upper membership function. So basically, it will convert the value from the input into a membership function. And then after that, we have the rule firing layer. This layer basically will just count, and also it will give us the value of how significant is each rule for the data. And then next, because we have a type 2 layer, so we have to with type reduction layer, which basically will convert the type 2 value into the type 1. And we have the diffusification layer, which basically we want to average the power of the firing layer and also the type reduction into all the value. And then last one, we have to see that we have memory neurons in both the diffusification and the output layer. So basically, this will help to report fast latencies and will contribute to the accuracy of this network. Yeah, that's basically it. So, as I discussed earlier, we have a rule-based initialization which uses the K-means clustering and WCSS, which can be operated plus sum of square and the elbow method. So yeah, here's the example. So for this, for example, we would take the maybe 4 here. I guess, yeah, 4 is good here. So as you can see, after 4, it's not significant anymore. So yeah, and then yeah, for the backpropagation or yeah, self-regulated approach, which has the objective of minimizing the cost function j, which is formulated here, and then the required change, yeah, delta wr, yeah, we can see the negative gradient of j, and also we have a derivation here, yeah, we can recalculate it next. So we have some experiment results that we will show. First one, SID, MG, and WIN. SID result, as you can see, very similar to the actual and the predictive. Performance very good, better than all the other networks. And also the same with Mackey-Glass, MG, and also the WinFit problem. As you can see here, especially the MG and yeah, the SID, you can see here, very significant and maybe even double speed. So I will give you a demo here. So I've already opened Visual Studio Code here, and let's make it even better. So I will run the command here. Yeah. Oh, so let's see. Python and main SID1 W4. Yeah. So basically, it is the code that I've already created for network earlier. Yeah, as you can see, elbow method. Basically, maybe we have to choose 4, but no, because as you know that I already tried 4, but it's not that good. So I will try 5 here. As you can see here, yeah, we have the R for stands for number of rule. We have 5. So yeah, let's continue. Yeah, as you can see here, epoch we have already set it into 150, have 5 rows, and then the RMSC will just decrease and decrease. And by the way, maybe I will just explain a little bit what my code here while waiting for the results. So yeah, basically we have the hyperparameter variable which will just set all the variables here, the parameter, eta, the learning parameter, decay parameter, yeah, and everything else. Yeah, it will be explained in the report. Yeah, quite complicated. Let's see, it's already 75. Okay, yeah, so many comments. Yeah, let's just wait for a little bit. Yeah, it's decreasing. By the way, if you see here, the first, yeah, it decreased quite fast, but as you can see, even earlier, 0.18 is already good enough, which means that, yeah, rule initialization and center initialization is very important, which is why K-means really helpful. So let's just wait a little bit more. Nice, 140. Come on, 10 more. Nice. So as you can see here, this is the graph. It's the same with what I already showed you. Yeah, it's very good here. Yeah, so basically it's very similar. Yeah, we close and then yeah, we get the RMSE. It's nice, very nice here. Okay, that's for the demo. So to conclude what I say, I think that the inclusion of memory neurons for dynamic handling, which we have already seen earlier in layer 5 and 6, is very important to have the past instance recorded and also the utilization of k-means clustering, as you can see in the demo, is really significant. And then yeah, self-regulatory learning using the application is always good for visualization. Yeah, so that's all. I hope that in the future there will be more improvement on this area of neural network, maybe utilize more neural fuzzy, fuzzy type 2, or maybe go even into a really different direction like the deep fuzzy neural network or something like that. Thank you.